preparation.
Mhm.
Number, hang on, let me go to it. The degrees of freedom.
Yeah.
I was confused on that one because, let me share my screen really quick. I wrote it down, I just don't have my paper with me. But I did not get, I don't know how they got that number.
The 2 and 120.
Yeah.
Did you erase the ones on variable? You got it.
Oh, is it like 2 and 1?
Comma 120. Yeah.
Okay, so 2 comma 120 makes it look like 2,100.
120.
How did they get that number?
Yeah.
Okay, so I did get it right.
Mm-hmm.
Okay, cool. Well, then I don't have any questions. Do you have any questions?
I don't.
Okay.
It's too funny. Okay.
I know. I was so confused. I was like, what in the world?
Yeah.
Like, there's thousands over here, but yeah, anyways.
Yeah. I didn't erase the like variable 5 and 6 initially. So it gave me like some really weird numbers and I was like, wait, this doesn't look right. Yeah. So no worries. I did the same.
Oh, that's funny. Okay. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different.
That's true, right?
Yeah. Pretty sure.
Yeah.
Come over here. I wrote really good notes. I should actually really just go get my notes out. Let's see. What requirements need to be checked when performing an ANOVA hypothesis test? Marked all that apply.
I know for sure it's the last two, but I remember it saying something about positive. Do you remember that?
So it says that F, the test statistic, will never be negative.
Okay.
But
that doesn't mean the sample means can.
Yeah, so I just say the last two.
Okay.
To check if each group is normally distributed, do the following. Construct a Q.
plot?
That's it, right?
Yeah. Mm-hmm.
Okay, we assume the variance in each group is the same if the following happens.
The second one? Yeah.
An ANOVA hypothesis test is equivalent to conducting independent two-validity tests with every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples?
4?
4?
Wait. Okay. I think I'm finally understanding what it's asking. So 1, 2, 1, 3, 2, 3. Okay.
Because it'd be like 1 and 2, 1 and 3.
1 and 3, 1 and 4.
2 and 3.
2 and 4.
3 and
3 and 4.
Wait, 3 and 4. So 6?
Yeah.
6, yeah.
Was it 6? 1 and 2, 2 and 3, 2 and 4, 1 and 2, 2. Oh my gosh, 1 and 2, 1 and 3, 1 and 4.
Let me just
and then, yeah.
I think okay, so we have 1 and 2, 1 and 3.
1 and 4.
4.
And then we have 2 and 3.
2 and 3.
2 and 4.
4.
And then 3 and 4. Yeah.
That's it, right?
6.
Okay.
Mm-hmm.
The data in the soccer shoes Excel was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away, 10 meters, miles, meters, from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. What is the minimum variance for the 6 groups? You need to open this baby up. And let's see. Okay, we'll do A. Where do you work, by the way?
I work at Nature Sunshine, but I do like taking calls, you know, talking to people all day. Yeah, is right. It's like customer service, basically.
Oh, gotcha.
Yeah.
Do you like it?
Yeah, they treat us good. And usually everybody who calls in is pretty nice, so.
That's good.
Yeah.
I hate that, like, when you copy and paste another thing in there, it, like, doesn't erase.
It doesn't erase the other ones, right? I think that's annoying, too.
Ah, I hate that stuff. Actually, I don't. It makes my life easier, but it still stinks. Okay, see. Also, I wish they would have, like, divvied these up better.
Yep.
Doing it, like, right on top of each other. Because like, that would screw up your entire data if you included just one E.
Yeah.
Into your D.
Okay.
Okay, that should be that. Close that out. Okay. So, what was the question?
What was the smallest variance for the 6 groups?
So, 7.
Yeah, that one, right? The 27.208.
Mhm.
Okay.
27.208. What is the maximum? So that one would be the 40. No, 53.
53.
Yeah, 53. The test for equal variances is sampling.
I am feeling better and
data.
definitely better than I'm not.
Yeah, that's true.
Wait, what?
Yeah, because that's the one where you take the smallest and you multiply it by 4, right?
Yeah, so if you do 27
times 4, that's not.
Oh, I think I misunderstood the question. The test for equal variance.
Yeah.
So yes, because it doesn't. Okay. 50 Q plot for each of the 6. The samples are approximately normal based. Okay, so I have a question about that. How do you construct the Q plot?
So you have to go to the quantitative Excel file.
So thankfully,
Yes.
Okay, so
and then you have to do lowest to highest.
lowest to highest.
Yeah, once you input them.
My wife's like, my wife. Yeah, she's got a way worse than.
I'm kind of confused on what you're saying.
Okay, so you take like variable 1.
Okay.
All of the numbers.
Just like copy them.
Mm-hmm.
It was, for her, it's just body aches.
Okay.
And then you're gonna paste them here.
For me, I was already.
Miss Blue Spot.
Yeah.
I've been fighting this for so long.
Okay. So now you have to go to where it says
It ended
data
up that he just gave me, what's it called?
at the very top.
Z-Pack.
Oh, right here.
Oh, but on the
Won't
other
do
one,
pages anymore.
right?
Wait, this is the right one.
And
I
so
thought that's the one for the other one we had on.
I feel like now when I exhale,
Okay.
I don't feel the
So you're supposed to do advanced filter, or
Yeah,
filter
I mean, that's
is what
what
you
it
do
is.
actually.
but it's still draining out.
And then click on the little arrow there
I'm gonna play on Friday. We'll see how it goes.
and then ascending.
Yeah. That's
Yeah.
okay. So what's up with this one all the way out here?
I don't know. But I think they just want us to make sure that most of them are.
Or normal?
Yeah.
So if I put
So like that one's normal right there.
yeah, then I copy and paste these.
Mhm.
And I can do the same thing.
Yeah.
Sounds pretty normal too, or are these ones too far away?
I think that's pretty normal. See, I never know. I can't decide.
I know, it's like,
How do I know if it's normal or not?
right. Okay, we'll do sending again. That one's pretty normal.
Mm-hmm.
So then variable 4. Copy and paste. Sending. That one's also pretty normal. I'm having a feeling it's going to be true.
Yeah.
Just to make sure though.
Well, you see, because these look really, really normal. How do we know if the other one was, like the second one?
Yeah, see this one looks super normal. That other
Mhm.
one was like kind of out here a little bit,
Yeah.
up here too.
I think that's okay, right? As long as it's like not all over the place.
Yeah, I think that's okay just so long as they're not like super duper far away. Because that one also looks pretty normal other than like this area right here.
Mm-hmm.
So we should just put true.
Yeah.
If you perform an ANOVA test, you will observe that the p-value is 0.81, correct. Remove the SOX data and perform the test again. What is the p-value when remove the SOX data? So we'll just click on this part and delete it. Then the p-value is 0.309.
So would it be 0.310? Wait, what am I thinking?
But you'd only round it if the 9 was in the 4th place.
Perfect. Okay, 0.309. Perfect. That makes sense.
The test statistic for the ANOVA test hypothesis test is an F statistic. Is the p-value the area to the right or the left of the statistic? To the right, right? Because it's right skewed. If you remember in the video how I did that.
Mhm.
I
And the F statistics over here?
over
Where would it be at? Like, I just don't get it then. I don't get the question.
so if we go right here,
Okay.
so the p-value would be to the right of the F.
Oh, okay. Perfect. Okay. That makes sense.
Okay, let's get this one up and running. Excuse me. Okay. Let's examine the calories first. Construct a QQ plots. Excuse me. Plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use an ANOVA test have been met.
So calories is what we're looking at.
So just calories.
Mm-hmm.
So what happened to my Q? And did I exit out of it? Oh, I didn't. It's right here. There's too many things open. Okay.
Yeah.
So then just calories, right? So I do beef
Right.
first. Just that one, and then put it in here. And then, does that look pretty normal?
Yeah.
Do meat. Copy that. Is that, uh-oh. What about this one though? Like I just don't know.
What's normal?
Yeah. Because like what I thought was normal on my last exam totally was not. So, see, but that looks pretty normal. Like it's not
That
really.
does.
So, the assumptions have been met. It is safe to assume each group comes from normally distributed. We can also assume that the variances are equal.
So the variances are equal, that's for sure.
Yes. I'd say the first one, they all looked pretty normal, and if not, then we can choose the third one.
Yeah, okay.
Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51. That F is, am I going to need this Q plot thing again, or can I? Yes, gosh dang it. So let's put, move this back up here. We only have 3 this time. For the calories, right?
Mm-hmm.
Okay. See.
So I think it gives you all the information though.
Gosh dang it.
Because it told you the p-value and it told you the level of significance.
Mm-hmm.
And so it just wants us to draw the conclusion based on that.
Okay. I'm just gonna put this in anyways, just in case we need it.
Okay.
So that'll make our life easier. Ah, was that supposed to be up one? Doesn't matter. Gosh dang it. Ah, what the heck? What in the world? So stupid. Let me just try this again. There we go. Okay. with the levels, what conclusion can you draw? So 0.000 is smaller than 0.05, so we have sufficient evidence to claim that they all have around the same.
Well, we're rejecting the null,
Exactly.
and so the null says that all of them have the same, or they have a mean, right, of the same calories.
So the null, we're assuming that the null is that all means are equal.
Okay.
So if we're rejecting it,
So that means that there's different.
so it'd be
Yeah.
number 3. Now let's examine the sodium levels. Construct Q. We should see that the Q plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7,180 and the largest is 10,492. Have the assumptions been met to use the ANOVA? Should I put them into the thing again?
I don't know, because these word problems trick me.
I know, because
it's already telling you.
it says.
Okay, well, it says construct QQ plots.
Okay, let's just do it. For the sodium.
For the sodium on the poultry.
On the poultry.
Yeah. Well, it says each of the 3, but why is it just talking about the poultry?
You know, that's a great question. That is less normal. Because this is like all the way out here. Yeah, so, I know why it's just talking about the poultry.
Oh, because it just wants us to, yeah, because it's just telling us the variance.
Yeah. So it's telling us that the poultry is not normal, but the other 2 are.
But why isn't it normal? Because of the QQ plot?
Look how far this is away from the thing, from the line.
Okay.
So, have the assumptions been met? No, right? Because they all have to be normal.
Yeah. But is it the third one? Because the variants are equal.
Yes.
So the third one?
Yeah, I would say so. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same in all 3 groups. What is the p-value for this test? Oh, I have to put in the sodium levels.
That's funny.
I just copied and pasted that. I should be able to. Heck yeah. Okay. I am struggling. Beef copy and paste. Okay. So the p-value would be 0.179.
Mm-hmm.
What conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? Use level significance 0.05. We don't have sufficient evidence, right? Because it's bigger.
Right.
So we don't have sufficient evidence. Oh, well, that's the only.
No, but that's fail to reject. Because what we're doing is failing to reject, right? So we have
Right. So if
sufficient.
we're failing to reject, then we don't have sufficient enough evidence.
To reject the claim that all 3 hot dogs have the same mean sodium levels.
Mm-hmm.
But isn't that what we chose before?
Well, no, I just remember watching the video today, and it was very like clear
About that?
Yeah.
Okay. Okay, let's go with that then.
Okay. That's the only one that says we don't have sufficient enough. I don't know. I guess we'll see.
Yeah. Okay.
We got 15 wrong. That was the only one we got wrong, though. So then, okay. So run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F is 16.074, and that P is 0.000. With a level of significance equal to 0.05, what conclusion can you draw?
I think it was the first one.
It probably is the first one.
Because we're rejecting the null, not the alternative. And this was the alternative, right?
Yeah. Well, yeah, so because the P is smaller than 0.05, then we're rejecting, right?
Yeah.
So then it would be the first one. So we can just go back and do that on our own.
Okay. That at least one of the hot dog types has a different. Wait, or is it the last one?
We have sufficient evidence to claim that at least one of the hot dog types.
I think it's that one.
I think so too.
The last one.
Mm-hmm.
Okay.
Okay.
Okay. Sounds good.
Cool.
Last one. Okay. Perfect. And then are we planning on Wednesday?
So I don't know if we're gonna do Wednesday or not because did you get the email?
Yeah.
So she said that she's doing hers at 6.
Mm-hmm.
So I don't know when you'd want to do ours. We could just do it after or whenever you want.
Yeah. I have institute.
You have institute?
Yeah, at 7. I don't know. When should we do it? Should we do it early in the morning?
I mean, we can.
Yeah.
You want to do it on Thursday or do you want to do it tomorrow? Or we could do early on Wednesday too. That's totally
Yeah. We could do early Wednesday.
early Wednesday.
Yeah.
Okay.
Okay.
Yeah.
I'll send the link then.
Okay.
Should we say 7?
7? Yeah.
Does that sound good? Okay. Perfect.
Awesome.
Okay.
See you
See
on
ya.
Wednesday.
Bye.